All right, we're still in Chapter 8, Lesson 1, and we're starting to talk about factorial notation. This is when you see a number with an exclamation point. So, for example, if I see the number 4 with an exclamation point, that means 1 times 2 times 3 times 4. Well, 1 times 2 is 2, times 3 is 6, times 4 is 24. So that's what factorial notation means. This funny little formula down here kind of explains that you go all the way up to n. Now, there is a special case. 0 factorial is not equal to 0. It is equal to 1. Please take note of that. Anything to the 0 power is 1. 0 factorial is also 1. You will need to have a couple of these factorials memorized. You will need 1 through 5 memorized. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, and you don't need to know this 10 down here. I just put it there because it's kind of fun. 10 factorial is, I need my highlighter, 3,628,800. All right, so where are we going with this? Write the first 5 terms of the sequence given by a sub n is equal to 3 to the nth power plus 1 over n factorial. Now, it's telling us in the directions to begin with n equals 0. So if n equals 0, that's where we're beginning. Well, remember 0 factorial is 1, so I know on the bottom I'm going to have 1 here. And 3 to the 0 power, anything to the 0 power, is 1. 1 plus 1 is 2. So my first number, you know what, I'm going to write these up here, is 2. All right, let's go ahead and plug in 1. 3 to the first power plus 1 is 4 all over. Well, 1 factorial is also 1, so that's going to be 4. Next number, 2. 3 squared is 9. 9 plus 1 is 10. 2 factorial is 2, so I know this is 5. Next one, 3. 2 cubed. Sorry, that's a 3. 3 cubed is 27 plus 1 is 28. All over 6, which is going to give us 14 over 3. All right, now let's go ahead and plug in 4. 3 to the 4th power is 81 plus 1 is 82 all over. 4 factorial is 24. It looks like that's going to reduce to be 41 over 12. All right, we are going to look at these right here. The question is asking us 9 factorial over 3 factorial times 7 factorial. Now, if I had to do this by hand, I would do it as 9 times 8 times 7 times 6, 5, 4, 3, 2, 1. Well, notice I have 3 factorial and 7 factorial. Do y'all notice that you could reduce a whole lot of stuff right here? So I probably wouldn't even write it all out. I know that this 7 factorial is going to cancel with all of that. I know 9 and 3 is going to cancel. 8 and 2 is going to cancel. And the answer is 12. So with this one, I would probably do the same thing. So I probably would take, on the bottom, I know this 4 times 3 factorial over this 3 factorial, so all of that can reduce. And then 8 times 7 times 6 times 5 times this whole factorial can reduce with this whole factorial. So do you see how I can make it so much easier by doing that? And 4 goes into 8 too. So 2 times 7 times 6 times 5. When I throw that into my calculator, I do get 420. Now, if you look on your TI-84, you will see that you are going to be able to go to Math, scroll to Probability. In number 4, you're going to see that factorial sign. But make sure in your calculator like if I was to go ahead and do this one on number 6A, I would go ahead and throw the fraction up first, and you have to put the number 9 in first, and then hit math probability 4, and all that factorial will come up. 3 factorial, 7 factorial, and you'll get the same answer. So please feel free to do that. All right, we are also moving on to talk about summation notation. Last year we did this in Algebra 2, but we didn't really talk about what everything stood for. So summation notation is this funny looking sigma, also called sigma notation sign. The top, the n, is what we call the upper limit. That's where you're going to end. The I is the index of summation, and the L is the lower limit. So let's go ahead and see how this comes into play. This is just an example of what they're saying. So notice they're using this equation right here of 3 times I. This is not an imaginary number I. I actually don't like it when they use I. They're saying, hey, we're going to start on the number 1, and we're going to end on the number 5. And that's the lower limit and the upper limit. But in between, we are going to add everything together. So notice they're putting in for 3 times 1 times 2 times 3 times 4 times 5. They actually factored this. I probably would have added it all together. But the answer does become 45. Now, let's go ahead and see if we can write this out for B. This is saying the lower limit is 1, the upper limit is 4, and we're putting it into this equation every time and adding it. So the first, sorry, I need a pen. The first would be 4 times 1 plus 1 plus 4 times 2 plus 1 plus 4 times 3 plus 1 plus, my upper limit is 4, 4 times 4 plus 1. And when I go ahead and find out what all of that is, I end up getting 44. Now, just like we talked about how we can use the factorials in the calculator, you can also use summation notation. So notice on the TI-84, if you go to math at the number 0, you will see this sigma notation or this sigma sign come up. You'll have an empty space for the upper limit, an empty space for the bottom limit, and I would just use X, and remember to the side you're going to go ahead and put the equation. Now, I would highly recommend that for homework you don't just go ahead and do all of them on the calculator, because remember you'll have some on calculator and some not on calculator. So go ahead and try these and push pause, and I'll tell you what I get. All right, so for these two, when you put this into sigma notation and you have 2 plus k to the 3rd power, we're starting on 2. I'll actually put it in. We're adding 2 plus 3 to the 3rd power plus 2 plus 4 to the 3rd power plus 2 plus 5 to the 3rd power. That answer was 232. Did y'all get that? In this last one, I'm just going to show the answer here. We're going from 1 all the way to 6, but notice this is a factorial, so you will want to put that in on your calculator. I got approximately 3.43611. I just showed it as a decimal.